Hey everybody, sorry, I was just getting my notebook ready. Uh, we're only two of us in here so far. We've got maybe 1 minute till class is supposed to start, but only two of you are here, but I suspect more will be coming.
Uh,
Uh, how's everybody doing?
can you hear me?
Yes.
Okay. I'm in the classroom with two others so far.
Okay, cool. Appreciate it. This is Zach and Mark and Kyle. Good deal. Yeah, I assume Miss Flax or Dr. McCaig caught you.
Yes.
Good. Good deal. I know Caitlin's coming. I suspect she's doing it from home because she was in communication with me via email last night and everything. Uh, there's other people too, so I suspect they're all coming. But you're f free to ask me questions now if you have any particular questions on any practice material that was problematic for you or anything. You can pull from any past homeworks, any past tests, any of that kind of stuff. And I have decided I'm not going to cover any more material. So chapter 21 is the end of the material. I'm just going to spend this week to help you guys prepare for the final. So I open the floor to any questions you might have.
When is our final test anyway?
What's that now?
When is our final test anyway?
It should be a week from today. So at your normal class meeting on Tuesday. But what I am going to do is in principle, you will be able to take it on Monday if you'd prefer. I'll have several times that day. You can take it on Tuesday. I'll have a couple times that day. And that's pretty much it. I might allow you guys a couple of times on Wednesday to take it, but they would have to be morning. And that's open to basically everyone. So all my students that are taking face-to-face tests can take exams during those times, which will probably be like 8:30 is an option, 9's an option, 9:30 is an option to start, and 10 will be an option to start. I think I might have a noon would be an option to start as well. But that's just on Monday and Tuesday. Wednesday will be a little different maybe. And you can choose to do any one you want. You don't necessarily have to let me know which one you're planning.
Is
I have
uh
a question.
next class gonna be a Zoom meeting as well?
For today, yes. I don't know about next time. I'm hoping I'll feel better by then. I think I might have passed my kidney stone or whatever, so I just feel a lot better. I had a bad night, but I feel a lot better, so I'm thinking I'll be able to come back on Thursday, uh, or at least tomorrow. So if I'm back tomorrow, then I'll definitely be back Thursday.
Is the final going to cover all of chapter 21?
It'll cover everything that we covered so far. So, if you look at the last examples we did, that's the last material that we covered. I think I went through parts of AC circuits, but I didn't actually do like resonance. Actually, let me look at I'm going to look at the table of contents from chapter 21 and see exactly what we did cover, and that might help you. Yes, we did do AC generator. Transformers and transmission, even though I didn't explicitly show example recently, I've shown an example before. So I would say 21.7 is included, but other than that, it's just up through 21.5. So 21.5 is electric generators, 21.7 is transformers and transmission power lines. So those two sections are fair, but everything else, just the stuff before it.
Okay. And
Okay,
another question.
good for it.
Uh, one of your past emails, you were talking about something to do with the face-to-face, taking the face-to-face test again for extra credit.
Oh no, yeah, yeah. So it's not well, yeah, I guess it is. So I've been advising everybody to take your old face-to-face tests and make sure you work them out and learn how to work those particular problems because I haven't assigned any problems that I felt were excuse me, that I felt were too difficult for the class, but I do know that I had several grades that weren't that impressive with the face-to-face tests. So what I'm trying to do is instruct you on what you should always do. So for instance, when you take a test in a college course, and whether you do good or bad, once you have the chance to get that test back, the very first thing you should do is always figure out how to do every problem that you did on that test. So I've been advising people to do that mainly because you should, but also because there was a chance that I was going to use that as a extra credit assignment in each case, in each of the three previous tests or two previous tests. I was going to use that as a way to give you extra credit points on those face-to-face tests. Ugh. So what I advise everybody to do is, since they're face-to-face tests, they require a lockdown browser. So you'd have to open your lockdown browser, go to your Canvas page, go to your grade book, click on with your lockdown browser, uh, log into your lockdown browser, then go into Canvas, then click on the grade in grade book for one of the face-to-face tests. And then I recommended you literally take a screenshot, which in this case, since you're in lockdown browser, you're probably going to have to actually use your phone to take a picture of every question in the test, including the answers, so that you'll have those available to you. And then when you're done with that, use that to cut and paste those photos of at least the question part into a document, and then solve the problems with those questions and then turn that in. I don't need an actual printed copy of the test redone, but I don't want I can take an electronic file, in other words, but what I definitely don't want to do is I don't want to have to just read a solution and not know exactly what the wording and the answer choices are. So, as a bare minimum, I want each question to start off with the actual question. I would prefer that the multiple choice answers be next, and then your solution below that, and then the next question start anew. Uh, so do that in an electronic file, or take screenshots of or photographs of your actual written work and then paste that under it. It would be fine as well. Then you can send the whole thing as to me as a PDF, which is more well, it's easier for me to deal with and less likely for you to have to waste paper or get any viruses to me or any of that kind of stuff. So that would be the best scenario. Worst case scenario, though, you can still print that out with the questions and the answers listed, and then your work would just be handwritten under it, and you turn in a hard copy. That would be acceptable as well.
Is it just the questions we got wrong or the entire test?
You got to do the entire test.
Okay.
Yep.
Just want to clarify.
And like I said, I hadn't made it an official assignment yet. That was just something I kept recommending you guys do for the last couple of weeks. Uh, but I'm almost certainly going to use that as part, if not the entirety of the assignment for getting
Okay.
extra points on your. I was making up something, but it just got so complicated. I felt like I maybe was putting a lot of work into something that you guys wouldn't get as much out of as I'd hoped. This happens all the time when you're teaching. You have this grandiose idea and you type up this grandiose Socratic method of walking students through questions, and then you realize, oh crap, not a single one of my students is going to pay attention to that long enough to do that thing. So, and it's not an insult to you. It's just saying that, hey, I realize I OCD'd it to death and made it so big that no one would ever want to do that. And they're probably not going to pay attention long enough for it to be helpful.
On your Gmail, you mentioned chapter 11, 14, and 15.
Ah,
Will that
that
be
was
in
for
our...
that was for physics 241. I'm sorry. I thought I'd put your 202 note above 241, so it made it misleading. But 11, 14, and 15 were chapters were from my 241 course, not my 202 course. You guys, if I remember correctly, is just 16, 17, 18, 19, 20, and 21. And of course, remember there were sections within there that I chose to skip, but the best indicator is what we've had on the past face-to-face and online tests. That's your best indicator of what you can expect on the actual final exam. Anybody else have any questions?
Uh, can you look at the chat when you get a chance? People are asking
Yes.
questions.
Yes, I saw the chapters 11, 14, 15. Will there be a Canvas assignment to submit the redo? Actually, let me make that right now. And yes, the final exam practice test, I expected to make it yesterday, but I just got hit really bad. So I'm thinking I won't be able to make it till sometime today. Probably when I get offline with you guys, I'll make it. Luckily, I don't have to do too much, but on the last couple of chapters, I need to be very specific about exactly which problems I choose. You know, I've had the problems where some of the questions came from a mystery bank. I got to make sure all those banks are clear, and I got to look for a bank or create a bank that only tests the parts that I think are most important, but does test those and test those a lot. So I hope I should be able to have it made sometime today. And that's for your class and for all my other classes, which I have a 202, a 241, or two 241s and two 242s as well. Will the final exam include questions from previous face-to-face tests? Yes. So my guarantee in my class is always that 80% of the points on your comprehensive final exam will come from that's at least 80% of the points on your comprehensive final exam will come from previous tests. So if you took your face-to-face tests and you took your online tests, and more specifically, remember with online tests, you got multiple choices or multiple attempts, and therefore there was a couple other questions you could have got in addition to the ones you did get. If you'd taken all those attempts for those online tests and all those face-to-face tests, then you'll have seen at least 80 points worth of the final exam questions. I'm going to basically make chapter 21 homeworks. Probably I'll make them do. Let me see if I even got the date set yet. Let me double check that real quick before I jump into an answer. I'm right here. Okay, there it is. Okay, now I'm checking the assignment due date. Chapter 21, as far as I was concerned, we were finished, but I want to make sure I set the date appropriately. So one thing I also want to remind you while you are here is since I told you 21's the last chapter we're covering, I want you to know that anything later than 21 is obviously extra credit, even if I don't mark it as extra credit. So I have all this. I'm looking at the homeworks right now. It looks like I had chapter 21 was due, both of them were due yesterday at 11:59 p.m. I'm taking from the answer that maybe some of you didn't finish chapter 21 before that deadline. Is that accurate?
I haven't finished it yet.
Okay. I tell you what I'm going to do is keep it till this weekend. So I'm going to take all of chapter 20 and 21, and I'm going to move those back to be due on, let's say, I'm going to have to say December 8th. The reason being because some of you may take your exam on Monday, and I just want to make sure you have that done before then. So, chapter 20, part 1, chapter 20, part 2, chapter 21, part 1, chapter 21, part 2, And everything else, which remember everything after 21 is extra credit, but everything else is also due on the 8th at 11:59 p.m. So if you want any extra credits, you can. It's not going to be easy. I mean, it could be if you just are using these extra credits, if you're just chegging them, that could be a really quick way of getting the points without learning anything, but that's not really my intent. My intent is in case you have other interests, this might be better for you, and also because you have the chance to learn even more material that might be more closely related to certain things that you're interested in. So I give you all these extra credit assignments that give you an opportunity to further learn maybe stuff that you might find more interesting or more related to your fields. All right, so I just set all those dates now. So they're done. Thank you for asking me that one. For the homework beyond chapter 21, do we only get 70 to get full credit? Yes. Yes, a 70 on extra credit. I usually used to do 80, but in that email I decided to do 70. So I'll just make that the official score for this semester, and anybody that scores a 70 on any of the extra credit is automatically a 70 or higher will automatically get the full score. I will have your lab grades input uh, probably by Wednesday night. I definitely would have it before your exam day. So they're definitely going to be done by Sunday, but I'm shooting to have them all put in by Wednesday night. Our final is online. Your final will not be online. It will be like the other face-to-face tests. So you'll come in uh, during one of those times that I've allowed for you to take it, and you'll log into a computer or you'll bring your own laptop. That would be great if you have it. If you don't have it, or it's too much trouble to bring, or it don't work on the TCC website or Canvas or the Wi-Fi, then don't bother bringing it. But if you can bring it, that'd be great. And you'll just take it on your computer uh, in my presence with the lockdown browser and with me and all your students in the room. Well, I say all your students, a bunch of students. It may or may not be your fellow classmates or not. Anything else? Caitlin, I do think I fixed all those due dates. Hopefully that's okay now. I was looking at your earlier post that I accidentally skimmed over.
Are you
What?
recording this Zoom meeting?
What's that now?
Are you recording this Zoom meeting? And if you are, how will we see this Zoom meeting?
Yes, the same way you've been the whole semester. So this is being recorded. It will be posted on my lab, or excuse me, on my YouTube channel. Uh, I was hoping you guys have been using this all the time, but either way, I'm going to go ahead and type my YouTube channel in the chat so you'll have it. It's www. Okay, so that's the URL for it. And I want to remind you, like, if you look in the actual notes for a particular video on that, you'll find something like this. I'm typing it right now. You'll find something like that. And usually they take the, like you see that underscore between the B and the 11. Usually YouTube just takes that underscore out. So you just see PHY 241 N02B space 11062024. And because of that, what you'll do is you can look at that particular string of letters in the description, and that's the actual name of the file that I use for the notes. So even 4 or 5 years ago, when I was making recordings, in those cases, they were actual photographs of handwritten problems on paper, but I took the photographs and I converted them to a PDF and I put them in my Google Docs. So you can go onto my Google Docs and do a search. For instance, if you wanted that particular video, you do a search for just the 11062024, and that should pop up the exact video, unless I happen to do two on one day, in which case you'd have to look for whether it's PHY 241, 242, 201, 202, or that kind of thing. But anyways, that's how that works. So today, for instance, today is 12/3. So you want to do a search. I think what I wrote was this. It's PHY 202 D01B. Again, it will be an underscore that I type, but it'll just have a blank when YouTube gets a hold of it, and it'll be 12032024. So that's the title you'll be looking for today, Mark. Or not the title, but it's the description in the actual text. So if you actually do a search on my YouTube channel for 1203 2024, this video will pop up once it's been uploaded to YouTube. As I said, Nathan, you asked about the date. I told everybody that your technical date for your final exam is a week from today, and technically it'd be at 9:30, but I'm actually offering you the chance to take it Monday or Tuesday, and I'm probably going to have some hours on Wednesday that you could take it as well. But it's one of those 3 days, and you don't have to let me know which one, but you're able to take it on any of those 3 days. And yours might be slightly different from someone else that takes it a little later, or vice versa. But they're going to be very similar in content as well as difficulty. So don't tell anybody, like if you're one of the people that take it Monday, you do not want to tell anyone what was on it. For starters, that's cheating. But also because you're giving them an unfair advantage, and that actually lessens the chance for your grade to be better. So there might be some overlap from, a person that takes a test on Monday, a person that takes a test on Tuesday, and a person that takes a test on Wednesday. There may be several questions or a few questions that they have in common. And if you, of course, took it on Monday and told somebody about it, then the people on Tuesday and Wednesday would have the advantage that they know at least a couple questions on the test, and therefore they get a higher grade. That makes the class average higher. That makes the chance of a curve or any of that less likely, and it makes the people that made lower grades look, less good. So, anybody else? No problem, Nathan. So this is a time, I mean, I'm trying to do this as a sort of getting together and letting you know what's going on in the future, but this is also a time where you can ask me questions. I can knock it short. I'm available to you for this whole what would normally be basically about a 3 hour period, or a little bit more than 3 hour period, because we were supposed to have lecture and lab today. So I'm available all this time by text, or we can stay online the whole time. But the main thing is, I want you to know you have access to me right now, and you'll have it again Thursday, whether by Zoom or in a face-to-face setting. And you'll have, the normal office hours between then and now as well. But all of those are times for you to ask me questions about physics problems that you had difficulty with in the past. But and that includes, you're actually trying to redo those old tests, and it's just the face-to-face ones, by the way. But you have the opportunity to ask me for help on that, and I'll give you some help. I'm not going to give you the whole answer, but I need you guys to treat this opportunity with those face-to-face tests as a chance for you to learn exactly how to do the problems that I thought were important for the face-to-face tests, because I thought they were important, which means in some sense, if you can do all those, then I have no problems with your whatever grade you make on the course. If that happens to be a perfect 100 on your final, then I'm probably going to give you an A for the class. I don't care if you got a 3 going into it. Uh, if you make a, 89, I'm probably going to be giving you a B for that. Since you made a B on a very high B on a comprehensive final exam. I'm probably going to give you that B for the final course grade, even if your grade works out to be a 72, because that's the way I work my classes. Is you have a opportunity to make an A even the very last day of class. Uh, the only problem with that, of course, is I'm putting myself at risk. If someone cheated, then they're going to have an A for a course that they didn't deserve. But that'll work itself out, not in a good way, but it'll definitely work itself out. Can I work through chapter 21 practice problems on Canvas? Yes, I can. I'm not going to do just a litany of chapter 21 questions. If you find any particular chapter 21 questions, I'll solve them. But I'm not just going to start solving, problem 21-1 and then do 21-2 and then do 21-3. Just choose the ones you want me to do so that you can make better use of my time. What was it? Practice problems. You talked about the can you work through chapter 21 practice problems? I assume that was from the practice test you're talking about, Caitlin? I didn't mean that to sound harsh. If it did, I realized it could have sounded harsh if someone misunderstood what I was saying. But so yeah, if you bring any of the practice test problems from chapter 21, even to the point where I work a whole one, that would be fine. But I'm just saying that's what I do. The practice problem quiz. Oh yeah, that's exactly what I was talking. Yeah, that's cool, Caitlin. I don't mind doing that. I thought you were just saying like, well, yeah. Anybody else has any more? Oh, let me go ahead and set my share. I'm setting the share for multiple participants can share simultaneously. So if anybody comes up with a question, you can, like on your computer right now, which obviously that would be more someone who's logged into the computer station in the classroom. Whatever account you're in, you could go to one of your practice tests and just zoom in on only the question without your score and all that sort of stuff. So try to choose your windows for wisely, or maybe even open other windows to hide your personal information like your grades or your names or anything like that. Actually, in an effort to avoid that, I tell you what, if you can find the problem, then I will look for it on my end. That way I can use the test bank and no one's grade will be, even a practice test grade, I don't think is cool to let somebody know what you made on it, even though, a lot of people take zeros just to see the questions. So I don't really want to do that. So can you go over question 19 from test 2? Yes. So what I'm going to do now is Nathan's asked me about question 19 from test 2. I'm going to go to our course and Canvas, which I'm bound to find any minute now. Okay, there it is. And I'm going to go to the grade book because that's the easiest way for me to find the tests. And Nathan, I'm looking for what you would be calling test 2. So are you talking about the last face-to-face tests we had, or are you talking about one of the online tests we had, or exactly what?
Yeah, I'm talking about the last face-to-face test. It was about
Oh yeah, okay, I got it. The F2F02 chapter 16 to 20.
yeah, it was the Spock landing on a different planet
Oh
and
yeah,
with electrons.
gotcha. All right, so let me see what's going on with this. Okay, we got Dominique in now. So I'm looking at that test, but that is not problem 2. So let me find the Dr. Spock one. I know exactly which one you were talking about.
It was problem 19.
Oh, that's right. You did say I said I was reading question 2 from 19. What an idiot. Sorry.
That's all right.
Here it is. Okay, yeah. So what we're looking at right now, let me see. I think the best way to do it, I'm trying to show you this without showing you everything. So let me try. I'm going to make my window a little smaller. That way we can I can look at a single question without showing you my entire test. Okay, so let me go ahead and share the screen now. So what Nathan's asking about is this question right here. It said, after landing on an unexplored Klingon planet, Spock tests for the direction of the magnetic field by firing a beam of electrons in various directions and recording the following observations. The electrons moving upward feel a magnetic force in the northwest direction. Electrons moving horizontally toward the north are pushed downward. Electrons moving horizontally toward the southeast are pushed upward. Mr. Spock therefore concludes the magnetic field at this landing site is in which direction? So I'm going to pull up my document and I'm going to make some copies of that question, or at least record the relevant information, and then I'll share that screen with you. So right now we said electrons fired upward. So I'm going to draw a coordinate system. You'll see it in a second, but I'm just telling you what I'm doing. I'm drawing a coordinate system first off such that I have north, south, east, and west. So I'm going to draw a little X and Y type of axes on my page. So I have north pointing what would normally be called into the page, east pointing to the right, west pointing to the left, and south pointing out of the page. And then I'd have the altitude perpendicular to both of those. So those are vertical on the page. And what we saw was when he shot electrons, when he shot them upward, he felt a force to the north. So, or excuse me, to the northwest. Electrons moving upward feel a force to the northwest. So with that, I'm going to say that's my velocity. And this is the force, which is pointing to the northwest. And I know I'm still not showing you the stuff. I'm just recording them all. Electrons moving horizontally toward the north are pushed downward. So now I'm going to say a different color for this particular experiment. So electrons fired northly. They're pushed downward. So what I'm going to say is this is the force. And electrons moving horizontally towards the southeast are pushed upward. So horizontally towards the southeast are pushed upwards. I'm going to use green for that color. So this is V E minus, and then those things are pushed upwards. So the force for this one would be F. Okay, so I've gotten all the information down. Now I'm going to go ahead and kill this question and show you the screen instead. So everybody see this, and they claim the answer is toward the southwest. That's supposed to be the correct answer. So I'm going to stop sharing there, and now I'm going to share my iPad screen with you. Okay, so does everybody, you should be seeing my screen in a second. Everybody see that? Anybody not able to see it? Okay, so remember what we're doing here. We're using the QV cross B. In fact, it's actually, I have a nice drawing that might be helpful to you guys. Let me get my 3 calc problems, no. I have one file that might actually be super helpful. Let me see if it's in here. No, it's not there. That's another problem. Maybe I put it in calculations. I'm not sure. I had made a really nice drawing of a hand so I could help you guys with right hand rules, but now I'm having a hard time finding it. So I guess I'll just stick with this. Okay. All right. So the way our right hand rule works is we're dealing with the force on the electron. Now, you guys are unaware of this because we haven't talked about this specific mathematical operation called a cross product, but I'm just going to write it down for completeness. Some of you that maybe have had such experience might benefit from it. If you don't, that's okay. Don't worry about it. But the formula is technically force is equal to QV. That's one vector. And then there's this fancy thing called cross or called a vector product. So when you have this old school multiplication symbol between two vectors, that's called a cross product or a vector product. And what is supposed to happen is if you take two vectors, let's say vector A and vector B. Now I'm drawing these, ooh, that was pretty bad. I'm drawing these on the page and I'm expecting them to be exactly on the page. I'm not trying to draw a three-dimensional figure or anything. So they're literally exactly the direction they're supposed to be on the page. So the A vector goes up and to the right, the B vector goes down and to the right. What I have to do is if I want to calculate vector C, which is A cross B, my right-hand rule helps me with that because it turns out the magnitude of C is just A times B times the sine of the angle between them. That's the formula you're used to seeing. This is the angle theta. In other words, the vectors are supposed to be tail to tail for you to find the actual angle theta such that C equals AB sine theta is the formula. Or for you guys, of course, we're using F equals QVB sine theta. So as far as the cross product goes, if we draw a hand, and I apologize for my inability to draw a little better. So that's going to be your index finger. And now my ginormous thumb. I don't know what happened with that, but now I have a ginormous thumb. Now my decidedly enormous girl type thumb and my decidedly small wrist. Okay. All right. So that's what the right hand rule is supposed to look like. This is your vector A. Notice it is right hand. This is your vector B. And then if you realize, we can trace this back. And what we'll realize is this vector right here, C, is perpendicular to both A and B. I'll write it right here. C is perpendicular to both A and B. Okay, So if you look at this thing in order, look at the diagram A and B, and then notice the thumb. What I'm going to have to do with my hand is hold it like this. That's the way it's being held right now. But I need my first finger to be in the direction of A. I didn't write that on there, and I should have. So my index finger has to be in the direction of A, so I hold it like that. Now my hand is free to rotate through all these different angles right now because all I know is vector A. But what I have to do is figure out where vector B is, and my finger, my middle finger, that's allowed to be basically anything but 0 degrees and anything but 180 degrees. Long as it's not 0 degrees or 180 degrees, then any position's okay with that middle finger. So I've got my index finger parallel to vector A. So that means it's like this. Now I'm going to rotate until my palm is actually pointing out, uh, well, that way. That way over there. Okay. Now my middle finger is pointing exactly parallel to B, and evidently my thumb is pointing into the page, and that's where C is. So the C vector on this case would be pointing into the page, which I'd represent by, let's say, this direction. Oops, I wanted to use a different color than that. It's going to go into the page. Notice I'm trying to draw it parallel with the north-south line on that diagram over there. And I sort of made it like a cone-shaped arrowhead, so you can sort of see that we're looking back. But the main thing I want you to understand from this is that it is definitely perpendicular to this vector, and it's definitely perpendicular to this vector. And it's into the page. So that's what we're using to figure out what the direction of the force is. In this case, we had A and B, and A cross B gave us the blue vector C, and that resulted in B going into the page. I've got a little problem in that the blue lines are in front of the purple lines, so they made it look the opposite of 3D. So now I'm fixing that, and hopefully that'll address it to some extent. Okay. All right, so now that we have that and we understand that F is equal to QV cross B, the other thing we got to realize is, hey, if I multiply like I have here, notice the vector QV, that's all one vector, even though it's a scalar Q times a vector V. It turns out if you multiply a scalar by a vector, if the scalar is positive, the vector only gets shorter if the scalar is less than 1, or longer if it's bigger than 1. But if it's negative, it turns around 180 degrees and also gets bigger or smaller depending on whether Q is less than 1 or bigger than 1. So when I draw all these V's for the electron that Spock shot out, then what I have to understand is the QV is going to be the opposite direction. So what I'm going to do right here for the first one, y'all see the red vector that says VE minus? I'm going to go ahead and draw that in black and say that this is QV. Okay, so this is QV right there. That's supposed to be my first vector, so I'm going to put my index finger in the downward direction because that black vector is in the downward direction. Now I need my middle finger to point off diagonally into the page halfway between north and west. So that's not the easiest thing to do, but it appears in that case that we want the force. Actually, no, sorry. I don't want my middle finger pointing in between north and west. I want my thumb to point between north and west because that's the direction of the force. So I'm doing my QV down. Again, velocity's up, so QV is down. And now I want my force to point to the southwest. That means a lot easier than what I was trying to do. It just turns like this. So what that means is my magnetic field could be anything other than 0 degrees and 180 degrees. But in principle, if it was perfectly perpendicular, the magnetic field would point to the southwest. So the red one compels me to think that it points somewhere between, well, down and southwest and up and southwest. So I'm going to write it right here, and I'm going to write it in red. Red with black vectors suggest B is pointing toward the southwest and may have an upward or downward component. Oops. So that's what I got from the first one is notice if in fact magnetic field pointed exactly southwest. Okay, I'll draw it here just to pretend for a second. Let's imagine the magnetic field pointed there. That's like a hypothesis for us. Now, if I pointed my index finger in the direction of the black vector, which is downward, and then I pointed my middle finger in the direction of the magnetic field, you would see that the F points in exactly the same way that we were told. Specifically, it points to the northwest, and I think they said horizontal there. Electrons moving upward feel a magnetic force in the northwest. Oh, yeah. So it didn't say necessarily whether it had an upward component or a downward component or anything like that. So, yeah, it's just to the southwest. So this first piece of data seems to be correct. We've got that. Now let's do the purple one the same way. So the purple one, again, is a velocity for electrons. So we have to decide on a QV vector. So again, I'm going to use black. Actually, for this one, I'll use a dark blue. That way it's still a different color. So this vector is QV right there. So now what I have is QV pointing out of the page like this to me. And I want my thumb to point down because that's what the purple vector shows back there. So if I do this, you see my index finger is pointing to me, which is the direction of QV. My thumb is pointing down, which is the direction of F. And my middle finger can point anywhere from between 180 and 0. So mostly my middle finger is going to be pointing again to the southwest. Anybody have any questions on that? QV, cross B, F. Yes. So for the purple one, vectors Now remember, your finger, your middle finger is free to be all the way out to 0 degrees and all the way up to 180, but not 0 and not 180. So when I do this, pointing the index finger directly at me, my magnetic field vector is clearly in the southeast quadrant, but it could be completely south, or it could be completely west, or it could be even well, no, that's about it. In principle, it could be even as bad as somewhat to the north. But the main thing is the southwest is definitely getting the right directions. Okay, so I've got that for the second vector. Now I want to, or for the second condition, now I want to address the green ones. So for the green ones, we had electrons being shot in the southeast direction, and the force caused them to point up. So I, again, am going to have to create a QV vector that is the opposite direction of V sub E minus. So this time I won't use blue. I'm going to use this light green color. And I'm going to say that this vector, this little green guy right here, is QV. Okay, so I've got the QV vector, which is the opposite direction of the V vector in green. So you see now that QV vector points to the northwest and is in the horizontal plane. So my index finger has to go in the horizontal plane, but it specifically has to go northwest, which is, like 45-degree angle north of west. Then my force has to point up because that's what the other green vector shows. So that means I've got to do like this. That means my middle finger can be as far as due northwest, but just a little bit shy of that because it can't be 0 degrees, or it could be due southeast, but it can't be exactly due southeast because 180 is too big as well. So again, I get a magnetic field that points somewhere in the southwest. So with the green ones, I reached the conclusion. So basically, what we were able to conclude is that all three of these are exactly consistent with the magnetic field pointing to the southwest, and that is the actual answer. It says towards the southwest. Anybody have any questions with that one? Hopefully that intro to the right-hand rule, I know it's like your 15th intro to the right-hand rule for you guys. I apologize for that if that was a problem, but hopefully it's sinking because I know some of you are still having some difficulties with the right-hand rule. So hopefully that will address it a little bit. So in terms of our class, rather than the random A cross B equals C. So for our class, what you might think of is this is our hand, our right hand, of course. There's our middle finger over there. And I'm just drawing it over a little neater in black, if you will. Now, what we're going to do is we're going to say the vector of the index finger is QV. The vector for the middle finger is the magnetic field, which happens to be B again. And the vector for the thumb is the force. So that's the way we adopt this right-hand rule for QVB sine theta. Anybody have any questions on that? Okay, I need to see my chat. Okay, there it is. Cool. I lost the chat, but I was showing something else instead, and I don't know why this is there. Okay.
Is the formula sheet going to stay the same?
Yes, I don't think I made is the current formula sheet. I think that has everything through 21, doesn't it? If anybody sees anything missing from chapter from 16 through 21, then let me know and I'll make sure I put it on the equation sheet. But right now I'm under the impression that I had already done it for chapters 16 through 21.
Okay.
Okay, I'm reading Caitlin's note now. Nathan, did that answer your question regarding number 19?
Yes, it did. Thanks.
Okay. Hopefully that wasn't too terribly confusing. I know I had to back up and show stuff, but I know you are a little further along than I was suggesting by my solution, but I wanted to make sure everybody was sort of following me, so I tried to go over this with from the very beginning where we had to introduce the idea of a right-hand rule and what the QVB sine theta means. So in general, everybody, when y'all see a formula that something times a sine of theta, in the physics world, that's almost always because of this crazy cross product thing that I just demonstrated for you. So hopefully that'll give you a deeper understanding of why formulas often have a sine theta in it. If they have a cosine theta, that's a different one for picking out the components that are parallel, whereas this sine one is for picking out the components that are perpendicular. All right, I'm now looking at Caitlin. Says, I'm looking through chapter 21 practice problems on Canvas, and it appears most of the questions are just from chapter 16 through 20. I'm not finding chapter 21 problems. Oh, yes. That's crazy. Oh, you're looking at the chapter 21 practice problem. Okay, well, let me check that real quick. Everybody, while just for a second, I'm looking at Caitlin's comments, and I might have accidentally made my chapter practice. I might have made it incorrectly. So I'm going to the modules real quick just to make sure that's not the case. And if it is, I've got to fix it because obviously that's what you guys use to practice. So I'm looking at chapter 21. Let's see if I accidentally put in the wrong chapter. Edit. Questions. Well, wow, it's exactly the wrong chapter. Isn't that just super helpful? Okay. So I don't think, let's see if I can do it this way. I'm going to fix it right now, everybody. So one question, 1 point, and I'm going to say chapter 21. Thanks for catching that, Caitlin. I can't believe I had that, nor that I had never caught it before. That's really terrible. So now I'm doing chapter 21. Won't take but a second. Well, in principle, won't take but a second. That's the wrong one. There's the right one. Chapter 21, conceptual. And now I'm going to do 3. And they're 3 points each. And this time it's going to be chapter 21, calculation question. And 7th edition, yep. Okay, so I'm going to ditch that guy. Yeah, I completely had the wrong chapters in there, Caitlin, but it's fixed now. Thank you for that. It says, when you have a moment, would you please be able to review the question bank? I may not have worked through enough. Yes. Excellent. Yeah, thank you very much for that, Caitlin. It is now fixed. And because that's not one that records, it's like there's no problem for us doing that or anything because I never see your grades or anything, but now it's correct. So Zach says, can we go over question 8 from face-to-face test 2? So let me go back to that now. I'm going to do modules. Question 8 from face-to-face test 2. So I'm going to go to face-to-face test 2. I'm going to edit it, and now I'm going to go to chapter or question 8. So there's 1, 2, 3, 4, 5, 6, 7. I believe you are referring to 2 capacitors are connected as shown in figure with C1 equal 4 microfarads and C2 equals 7 microfarads. Is that the one you're talking about, Zach?
Yes.
Okay, good deal. So let me go ahead and share that screen. I'm going to stop sharing this one, and then I'm going to start sharing that screen so we're all on the same page knowing what problem it is. I'm going to copy down information to make sure that I have all the relevant stuff for this problem, and then I'll share my iPad with you. Whoa. That went the wrong way. Here it is. Okay, now I'm going to copy down information. It says 2 capacitors are connected as shown in the figure with C1 equal 4 microcoulombs and C2 equals 7 microfarads. If a voltage of 90 volts is applied across a combination, find the potential difference across C1. Okay, so this is sort of like what we call the opposite of a voltage divider. I mentioned to you guys when you put 2 resistors in series like that, you make a voltage divider where you can take the voltage across one of the resistors, R across the other resistor, and by adjustment of the 2 resistances, you can get a set voltage that's a fraction of whatever the total voltage is. This one's just like that, except it's capacitor. So I'm going to draw the picture on my notepad and what I call my good notes. And then I'm going to write down the values and then work out the problem for you. So what they showed was essentially the voltage is equal to 90 volts. I'm going to call that 90.0 volts just to have 3 sig figs. The C1 is 4.00 microfarads, and the C2 is 7.00 microfarads. Again, I'm adding an extra sig fig specifically because I want to get 3 sig figs and know exactly what we want here. What we want to find is V across C1. All right, now I've got the information. By the way, we can check our answer. This one suggests that the answer should be 57. So that's if this is done correctly, we should come up with like 57 or 56.9 or 56.7 or 56.5 even. Okay. So now that I've shown you all that, let's stop this share and I'm going to start sharing my iPad screen with you. Whoa, wrong thing. Okay. So what we're thinking of here is immediately when you put that battery in place where that 90 volts is, you might even picture the 90 volt battery as looking like this if you want. If that's the case, then what's going to happen is this positive side of the battery is going to compel all the free positive charges in that blue wire and all the way in this black wire. They're all going to run away and then stack up this top plate of the capacitance C1. And they're going to keep doing that. And as they get up there, that's going to compel the positive charges in this positive plate to disappear. And that's going to force them over to here onto the top of the C2 plate. They're going to compel all the positive charges in the bottom C2 plate to run away. And in fact, what's going to happen is all those positive charges are now going to go back into the negative side of the battery. Okay. Once that total voltage across C1 and C2 total is 90 volts, then the current's going to stop flowing. And even then, it really wasn't necessarily exactly speaking a current flowing. It was because current can't flow through open circuits, which is what capacitors are. But what we're doing is sort of something just like it by compelling the charges induced on the top plate to scare away the positive charges on the bottom plates. That's really what's happening. So what we can do is we can figure out exactly how much charge is going to go to C1 and how much charge is going to go to C2. But before we can do that, we need to figure out how much total charge leaves the battery. So to find out the voltage across a capacitor, we need V, which equals, remember C equals Q over V. Let me write it that way for starters. We need to use C equals Q over V to find V is equal to Q over C. Therefore, we need Q1 to find VC1. To find Q1, we need to know the total charge. Darn it. Charge that leaves the battery because Q1 equals Q2 equals Q total. Remember, that's the nature of it. If, 47 microcoulombs comes up to the top plate of C1, that's going to force negative 41 microcoulombs to appear on the bottom plate of C1, and therefore positive 47 microcoulombs on the top plate of C2, and therefore negative 47 microcoulombs on the negative plate of C2. In other words, that's just the way it is that in series. In series, the charges of the capacitors is equal to the charge of each other and therefore equal to the total charge. To find the total charge, we need the equivalent capacitance. To find the QT, we need the equivalent capacitance. I'm just going to abbreviate that capacitance. So what we know is for series, 1 over C equivalent in series is equal to 1 over C1 plus 1 over C2 plus ... So in this case, we're going to say 1 over C equivalent is equal to 1 over 4.00 plus 1 over 7.00. The least common denominator for this, you can see that the 4 doesn't go into the 7. But then you try 14, the 4 doesn't go into that. So then you try 21, the 4 doesn't go into that. And then you try 28, and the 4 does go into that. So what that tells you is we're going to multiply this by 4 over 4, and we're going to multiply this by 7 over 7 to get our common denominator. I actually just realized how small I made that, so let me fix that for you guys to make sure it's easy for you to read. So what I'm going to multiply by in this case is 7 over 7. And that's just multiplication by 1, so that's certainly fair and allowed. And then I've got 1 over 7.00, but in that case, I'm going to multiply it by 4 over 4, which again is also 1, so that's acceptable. So basically what I get is the numerator is going to become 7, and then the other numerator is going to become 4. 7 and 4 is 11. So this will be 11 over 4 times 7 is 28. And I'm trying to maintain the 3 sig figs. So obviously 4 to infinite number of sig figs times 3 sig figs gives me 3 sig figs. And the 7 and the 4 can add up to give me 11.0000. But again, the 3 sig figs in the bottom makes it be 3 sig figs. So the C equivalent is just 28.0 divided by 11.0. And if I do that math, 28 divided by 28 divided by 11 is equal to 2.54. And I'll carry 2 extra sig figs. I'm going to call that 5. That's 2 extra digits that aren't necessarily significant figures. And since I put them in microfarads, the answer comes out in microfarads. So that's the equivalent capacitance. So what we're now saying is the circuit is exactly equivalent to a 90.0 volt battery in series with a single 2.5455 microfarad capacitor, C equivalent, like that. And of course, whenever we have just one voltage and one capacitance, we know that C is equal to Q over V. So Q is equal to CV. And this means Q total, which is what we're looking for, is equal to C equivalent times V. So Q total is equal to 2.5455 microfarads times 90.0 volts. A volt times a microfarad is just a microcoulomb. So I'm going to say 2.5455 times 90. And that's going to give me 220. Whoa, Nelly. I can make that a 2. 229.09 microcoulombs is the total charge. Now that I have that, I can say that the voltage across C1, VC1, which I'd normally just call, and I'll say therefore, which I'd normally just call V1, is equal to Q1 over C1, which is the same thing as Q total over C1. So I'm going to put 229.09. Again, those are extra digits, microcoulombs. And I'm going to divide it by C1, which was 4.00 microfarads. Now you can see the micros cancel out. I'm just going to take this 229 and divide it by 4. And that gives me 57.2. Again, carrying 2 extra sig figs. I'm going to call this 7.3. So there's 2 extra digits that aren't significant, and that's going to be the voltage. We had looked up the answer, and I think they said it was 57. Let's double check that. Yeah, it said it was 57 volts. Mine rounds to 57 volts, and I, of course, use 3 sig figs. They only use 2. So, yeah, this is the correct answer. Anybody have any questions on that one?
No, thank you.
No problem. So that was clear to you, Zach?
Yes.
Okay. Uh, Toby, we answered that earlier. Your exam date is actually supposed to be at 9:30 on Tuesday. But I told all the students I'm going to have a litany of times on Monday that you can take it, a litany of times on Tuesday that you can take it, and then I might even have a couple of times on Wednesday that you can take it. You can take it on any of 3 of those. You don't have to know me, let me know which one you want, but you're welcome to take any of them. And they're going to be face to face in one of the labs. So JC21 or JC26, might even be JC28, depending on how many students show up at certain times. That's why I'm giving so many different times. One, that accounts for all my hours that I owe all my students by me sitting in multiple exam sessions for multiple different classes. But 2, it gives you a lot of freedom on what time works with your schedule, including your desire to just take the exam a little later than maybe someone else. I'm openly allowing that, but I'm allowing everybody to do it, so that makes it fair. So hopefully that was good enough for Toby. Brittany asked, are we stopping at chapter 20? I thought I read that in the email last night. When you saw chapter 20, that might have been something from another class, but no, chapter 21 is the last chapter we're covering, and specifically 21.5 and 21.7 are included. Anything later than that is not included. So that means I'm skipping 21.6, obviously, but anything later than 21.7 is also being skipped. You're welcome, Caitlin. Brittany, it says, copied from email for 202, I've decided I will not be covering any more chapters. So the remainder of our meetings will be used to help you all understand all the material you have been tested on to date. Practice final exam may be made accordingly. Make sure you complete all the redo of all the past face-to-face tests. I still may take them up for extra credit. Chapter 21. So again, I'm just going to type this out. I know y'all, some of y'all have already heard these answers, but I'm going to say chapter 21 is the last chapter covered and tested. It includes 21.1 to 21.5 and 21.7, but nothing else. Okay. Let's see. I got another comment from Caitlin down here. Yeah, no problem. Mark, if we do the test on Wednesday or Tuesday, will you still have office hours on Tuesday or Monday of next week? Yes, I'm definitely going to have some office hours on Monday and Tuesday of next week. I will definitely have the 5:30 slot or the 5:20 slot that I normally do on Mondays and Tuesdays. So I'll definitely have those. I'll probably even, if you happen to come to campus, I'll be administering a test. I can step out into the hall, or I can work quietly up at the front to to answer any questions as well. If I find that I'm being a distraction to the test takers, then I'd have to stop that. But generally, I will be able to. And yes, around 6:35 is the time that you'd show up if I was covering more material, but I'm not covering more material next week. So you're just open to showing up at 5:20, not 6:35. No more labs, that's correct. And yes, the exam's next week, right? Anything else? So, anybody have any other face-to-face type questions? I mean, we're gonna at least do this again in class on Thursday, so you have some more time to look over the face-to-face tests. And if you do that, that may give you more time to know exactly where your problems are. But you should definitely be immediately start working on the first face-to-face test. Make sure you can do every problem in that. Even if it takes you memorizing what I showed you and how to do it, because I made various videos to help you with that first test. Remember, I made uh, electric fields for about a dipole moment, the force on a particle near a dipole, the electric field at a point near a dipole. And then I did it 4 different ways. There was 4 videos I posted this semester specifically for your 202 class that handled all that vector stuff. So even if you have to memorize one of those solutions, that's fine, because a lot of learning takes you guys to memorize something that seems like absolute gibberish. And then over time, it seems less and less gibberishy or gobbledygooky. That's the official word, anyways. But over time, you actually understand a little bit more and more of what you memorize. And then ultimately, you can apply that in other settings and solve other problems. So that's really part of the process. It's not always the way it goes. Sometimes you just understand it immediately, and that's fine. But most of the time, when it's something completely new, you're just sort of memorizing and rolling with it. You know, that's how I taught myself Latin using Duolingo. They literally didn't give you any words, what they meant or anything. They just came out with sentences and said stuff. So you sort of memorize them, and then over time you sort of make sense of it. So by all means, do that. We will have access to that Thursday. I might even do Thursday again like this, as opposed to going in, mainly because I don't know that I'm finished with this. I've got really high calcium levels in my blood right now, and there's a good chance that this might not just go away until I have surgery to remove my uh, parathyroid, or actually the tumor in my parathyroid, or in my thyroid. But anyways, until then, I might still be sick, so I might have to do this again Thursday. And yeah, the class is only an hour and 20 minutes on Thursday, but I'm not going to stop it at an hour and 20 just because it's an hour and 20, unless I, have to go to the bathroom or have something come up, like, something really urgent. But yeah, I'm here for you guys. So anybody have any other questions on any other problems? It's okay if you feel bummed out that you didn't take up my whole time, but it's also okay to take up my time. Yeah, I understand. I figured that was a little bit what was going on, because obviously you didn't know this was coming, so it's certainly reasonable for you to not necessarily have finished that. And not everybody's been consistently in the class, so a lot of you haven't. Even if you are there, you don't necessarily hear everything I said, but I have said repeatedly for you guys to redo face-to-face test 1 and face-to-face test 2. So please start doing that. That's the most important thing you can start doing. Once you get that finished, the most important thing you can do is take the practice test, the practice final exam that I should have made for you today. And between those, you should have a ton of questions come next time. Until then, you can also send me text messages if you have a particular online problem, multiple choice, for instance, that you can't work or you're having problems with. Take a photograph of it, include the answers, because there are, instances of multiple choice questions where there's more than one right answer, but only one best answer. So I really need to know what answer choices you have available. But if you take a picture of it and then text it to me and tell me what problem you're having, I can help you out. Or if you just say, hey, I don't know how to work this, I can give you some pointers on how to start it. Sometimes I'll reply directly to you with a completely written out solution. Sometimes I'll reply with a few sentences to get you started. Sometimes I'll make a whole video on it because, several students have asked, or it's important enough that I want to do it. So all that's fair games on return. But feel free to text me. And I've got my phone set up where if you text me at 2 a.m. and I happen to be asleep, it's not going to interrupt me. So don't feel bad about texting me at 2 a.m. or 3 a.m. It's not going to bother me at all. I won't see it till the next day. Anyone else? Yes, I'm posting this recording, Brittany. It'll be posted probably within 30 minutes of starting, of finishing. Sometimes it takes a couple hours, but as long as my bandwidth is high enough for my internet, it should work. And of course, everybody's free to go if they want to. We've only spent an hour and 20 minutes, so we've basically done a whole class. I haven't accounted for your lab time. I would like you guys to maybe use this extra time for you to do the practice, or excuse me, to do the 2 face-to-face tests. So you can start that, and that would also give me time to make the practice test. Once I have your practice test, you should do that once you finish the face-to-face test redos. While I'm here, I'm going to go ahead and make a module for turning in the face-to-face test 1 redo. I'm going to go down to the very bottom and make a new week, and I'll put it there. Anybody else have any questions? All right. Well, I'm going to go ahead and call it. I will be here. Does any of y'all want to, do any of you just want to sit here with me online and just twiddle my thumbs and do stuff while you work on things? That's okay. That's a waste of of recording time because we won't be doing anything, but I'm welcome. I don't mind doing that for you for the time that I owe you. But you're also just welcome to go, and you can text me at any time. I'll be available for several hours. All right. Looks like everybody's just saying we're going to cruise, but feel free to stick around as long as you want.
Have a good day, Professor.
You too, Mark. Thank you, buddy. Thanks for coming, everybody. Thank you, Nathan and Zach Smith and others. And Caitlin. Oh, okay. Yeah, I bet you have a couple other people with you. That makes more sense. I assume Clarita's there too. I can't imagine her ditching class.
I'm
Yeah,
here.
she's here.
Can
you put the chat? That was Clarita.
Yeah, I bet you a couple
Oh,
other
wait.
people too. That's cool.
Yeah.
Anybody else have any questions?
No.
All right. Well, I'll let you guys go. Hey, and seriously, if you're working on it right now and you have a question, just text me. If it's important enough, I'll make another video and post another one. But y'all are free to do that. I'm just going to be sitting here on my computer working through my kidney stone, and I'm available for you all day.
Thanks, Mr. Younger.
Thank you.
You're welcome. Thank y'all, and say thank you to the teachers that helped me out if you don't mind. Have a good day.
You too.
Yep. Have a good one.
Bye-bye. Bye, everybody. Bye-bye.